Hello, thank you for joining our Tech Talk today on data lake migrations and modernization using Amazon S3. My name is Bonnie Bruno. I'm an architect lead for data analytics and storage solutions at AWS. I'm very excited to be here today and will try my best to make this fun, informative, and valuable to you. Note this is a very special week for our company. 15 years ago, on March 14th, also known as Pi Day, we launched Amazon S3 and AWS was born. S3 is now seen as the ubiquitous storage platform for data lakes and analytic applications around the world. Customers of all sizes continue to use S3 to store and protect their data. I'm currently working with a large customer that is growing their data lake from 30 petabytes to 300 petabytes. I'm constantly amazed by how fast our customers are growing and how easy S3 scales. That being said, there are some best practices you need to be aware of. My goal today is to give you some insights on what those best practices are, as well as how we can lower cost and modernize your data lake by migrating to AWS. I will cover some of our key services, migration approaches, use cases, and more. So let's get started. S3 has unmatched availability, durability, and scalability, and is one of the most secure data stores on the planet. We now have exabytes of data stored on Amazon S3. It is without question the world's #1 object store. We also have thousands of data lakes running on S3, and I can say without doubt it is the best place to build your data lake. S3 Intelligent Tiering is the first storage class to automatically adjust pricing based on object access patterns. This translates into great cost savings for our customers. For cold storage, S3 Glacier Deep Archive is a great choice. It's the lowest cost object storage in the cloud, and it's cheaper than using tape. Cost optimization is important to all our customers. Here are some interesting results we received from our cloud economics team. They did a study on over 1,000 AWS migration customers, and the results show consistent cost reductions when migrating to AWS. The study found that customers see an average cost reduction of 19% in overall IT infrastructure spend when moving to AWS. If you also include migrating databases and applications, the average cost reduction increases to 27% in overall spend per user. And if your organization has more than 1,000 users, the average cost reduction per user increases to roughly 42%. Using multi-cloud providers does cost more. If you use AWS exclusively, you could save and lower costs by 12% on average. Now, besides cost savings, the study found 3 other benefits customers typically see when moving to AWS. Staff productivity increases because less time is spent on server configurations, patching software, network maintenance, doing upgrades, etc. By moving to AWS, IT staff can spend more time on innovating and adding new services to modernize and transform their information systems. Customers that use multiple availability zones and regions for critical workloads benefit from better SLAs and see a reduction in unplanned outages. Lastly, build-outs and new deployments happen much faster when migrating to AWS. Let me switch gears now and talk about our data migration services. We offer a wide range of options to help customers move their data. For one-time large data migrations, customers can leverage our Snow family of products to move petabytes or exabytes of data. For ongoing migrations, you can use Direct Connect, which utilizes dedicated high-speed network connections between your data center and ours. Then run various tools to move data over this high-speed network. You can use tools like data migration services to migrate databases and Metastores. For data streaming, you can use products like Kinesis, MSK. If you have IoT devices, you can connect them to our IoT core services. I'm just highlighting some examples here. There are many migration services options available to you. Our migration team can work with you and help you decide the best migration solution to meet your requirements. As we progress through the presentation, I'll cover more migration scenarios and use cases. S3 supports different storage classes to help optimize cost. When you first migrate your data, or if you're going through ETL processing, you just want to use the standard S3 storage classes, as you'll be accessing this data often. However, when the data lake goes live, you definitely want to use S3 intelligent tiering, as that's the best storage class to save you money automatically. For cool data, I recommend using S3 standard infrequent access, and for cold data, either Glacier or Glacier Deep Archive is ideal for long-term storage. Note, Glacier does not provide immediate access to cold data. If you have applications or users that need fast access to cold data, use infrequent access or just stick with intelligent tiering. This will avoid unwanted timeout errors that you may get from certain applications or users that need instant access. Many customers are interested in our real-time data ingestion capabilities, so let's talk about that. Real-time data can be ingested and processed using Kinesis or MSK. I'll talk about MSK on the next slide. As for Kinesis, we have 3 services you should be aware of. Kinesis data streams. Think of this as a data pipe with a producer on one end streaming data and a consumer at the other end consuming that data. A good example could be a Spark consumer application that's processing web stats from Kinesis, where Kinesis is receiving logs from multiple web servers. Kinesis Data Analytics allows you to process streaming data on the fly. It's the easiest way to transform and analyze streaming data in real time. For example, you could filter out extraneous data in web logs with Kinesis Data Analytics within your data pipeline flow. Kinesis Firehose allows you to persist data directly to S3 Data Lake. Firehose scales automatically and can batch, compress, transform, and encrypt data streams. It's also a good service to help minimize storage consumption. As an example, Firehose can batch and compress filter streams from Kinesis Data Analytics and save them directly to S3 Data Lake. I'll discuss Kinesis more when we get into some customer use cases. I've seen many customers use both Kafka and Hadoop. I'll address how we migrate both solutions to AWS, but let me start with Kafka first. By the way, I've personally managed Kafka clusters myself at processing rates of 20 million records a second, and I could tell you Kafka clusters is not easy to manage, and I'm glad to say that AWS now offers a fully managed Kafka service called Amazon Managed Streaming for Apache Kafka, also referred to as MSK. With MSK, we take care of all the Kafka infrastructure management and maintenance for you. With a few clicks in the AWS console, you can create highly available Kafka clusters in minutes with settings based on Kafka best practices. You can migrate your on-prem Kafka cluster to MSK using Mirror Maker. Migration to MSK is done in 4 steps. Step 1, create your MSK cluster using the AWS console. Again, this should just take a few minutes. Step 2, you want to set up and run Mirror Maker on an EC2 instance that is in the same VPC of the MSK cluster you just created. Step 3, when Mirror Maker finishes replicating the Kafka topics, redirect Kafka consumers to your new MSK cluster and validate the data. Step 4, you can shut down Mirror Maker and redirect the Kafka producers and validate the data. That's pretty much it. You can get more details at this link here. Hadoop is used by a lot of customers, and it is a common data lake platform I see over and over. I personally manage many Hadoop clusters in my time, and like Kafka, it requires a certain level of skill and administration, and management of Hadoop clusters can seem never-ending. There are obvious drawbacks with Hadoop. A big one is the lack of separation between compute and the storage layer. Another is that HDFS requires 3x replication scheme, which could be very costly. Using Amazon S3 alleviates this, as S3 is scalable object store with no dependency on compute. S3 allows for more granular partitioning. This translates into better data processing performance. Also, by using products like Amazon EMR, you no longer have to worry about patching Hadoop software or doing upgrades. Moving to AWS removes a lot of administration overhead in comparison to managing on-prem Hadoop clusters. As a result of these challenges with self-managing Hadoop clusters, we are seeing a lot of interest in customers wanting to migrate to AWS. So let's talk about this some more. There are basically 3 migration approaches to consider. You can lift and shift your cluster to EC2, EBS, and S3. If you are new to AWS, this could be a good option for you. You can re-architect and modernize your entire big data and analytics architecture using AWS services. Or you could take a hybrid approach and transition existing applications and re-architect new applications when a need arises. In all cases, you have to move data to AWS first. So let's talk about some of the ways you can do that. As stated earlier, we provide many services to move data from on-prem to AWS. Depending on your dataset size and requirements, you could use a combination of these services like Snowball, DMS, Kinesis, etc. Or if you prefer, use open source or commercial tools to move Hadoop data to AWS using Direct Connect. For customers that prefer open source tools, I've seen NiFi and DistCP used many times with success. Hadoop can easily connect to S3 using an S3A client. You can use DistCP to move data, but I highly recommend you use S3 DistCP, which is our version of this DistCP that has been optimized to work with Amazon S3, and it also has more features. NiFi is interesting because it natively supports HDFS, S3, HBase, DynamoDB, and many other services. So depending on how many Hadoop services you use, NiFi could also be a good migration tool for you. I've seen WAN-Disco used for data migrations as well. They make a commercial product called Live Data Migrator. It could migrate data from active Hadoop clusters and keep things in sync. They also support migrating Hive metadata to AWS Glue. It's in preview now, but looks very promising. Bottom line, you have many options to move data to AWS. Our migration team can work with you and help you decide on the best migration approach. After migrating Hadoop data, you will need to migrate your Hive metadata before any data processing can be done. I mentioned WAN-Disco as one option. Let's look at some more. There are several ways you can migrate your Hive Metastore to the cloud. However, I typically see 2 approaches used most, which I'll discuss here. Customers can place their external Hive Metastore on AWS Glue, or Amazon RDS, or Amazon Aurora. Once you decide which service to use for your data catalog, you have the option to migrate your on-premise Hive Metastore one time, as I'm showing here, or you could do ongoing Metastore replication. This would require the use of a product like Database Migration Service, which we make. It's also referred to as DMS. With DMS, you can capture and replicate ongoing changes from your on-prem Hive Metastore and sync it with your external Hive Metastore running on either Amazon RDS or Aurora. Note, to use DMS, you will need a VPN or Direct Connect. First, it's important to understand what data catalog you're going to be using. And a data catalog is not limited to just Hadoop. A data catalog provides a detailed inventory of all the data assets in an organization. It's used to help quickly find the most appropriate data for any analytical or business purpose. Data catalogs are vital for analytics, so careful consideration is needed on which data catalog to use. If you're going to, with the external Hive Metastore option, you can go with RDS or Glue. And a lot of customers ask us which is the better choice. The answer to that is if you want full control of your Hive Metastore and you want to integrate with other open source applications such as Apache Ranger or Atlas, then put your Hive Metastore on RDS. This requires just a little bit of more administration. If you want full managed solution, then you want to look at Glue. It integrates with Redshift, Athena, EMR, and by the way, the Lakehouse architecture, which we've been promoting on our website recently, also relies on Glue. If you're considering that architecture, you definitely want to use Glue. However, before you make any decisions, I recommend you schedule an EMR workshop with our team to help you decide the best option for your organization. After migrating the data and the Metastore, your next task will be to migrate one or more Hadoop applications. The key here is to use the right tool for the right job. For example, if you require low latency SQL and you've been using Hive, consider using Presto or Athena or Redshift. Since your data is now on S3, you have access to a multitude of purpose-built AWS services. Consider integrating them to modernize your data lake solution. For data warehousing and reporting, consider using Redshift or Spark on EMR. For system monitoring, consider using CloudWatch, the AWS Council, as well as S3 Storage Lens. By the way, S3 Storage Lens is a really cool product. It provides a single view of your S3 storage usage activity across your entire organization. You can get all sorts of metrics. I would recommend if you're using S3, you definitely use S3 Storage Lens as well. These are just some examples. Our team has a lot of experience with migrating applications and Hadoop products. So make sure you engage your team as much as you can. We definitely want to help you. This is actually a good time for me to talk about our EMR workshop. It's a great service that offers a lot of value and best of all, absolutely no cost to you. We put this together because many customers are unsure on how to best migrate their Hadoop deployment to AWS. This workshop provides you with direct access to migration experts. It provides a lot of detailed lessons learned about other customer migrations. It will give you best practices to consider. You'll be granted access to free AWS resources and labs, which is very nice. And best of all, you walk away with a custom data lake solution and migration plan, which is specific to your very needs and requirements. It's a great learning experience and something I highly recommend you take advantage of. In addition to the EMR workshop I just mentioned, we have put together a very detailed EMR migration guide that covers migrating both Apache Hadoop and Apache Spark in detail. You can get access to the EMR migration guide and schedule your EMR migration workshop at the link I'm providing here, or just email us at emrmigrationhelp@amazon.com. We definitely want to work and help you as much as possible. Now let's talk about running analytics in the cloud. Depending on which migration path you chose, i.e. lift and shift or re-architect, your ability to run analytics is dependent on the platform and tools you use. For example, if you are a Cloudera shop and you want to self-manage your environment, you could simply deploy Cloudera on our core services like EC2, EBS, and S3. And simply use your existing applications and code and third-party tools. On the other hand, if you want more options to process and analyze data in place and use fully managed cloud services and leverage our pace of innovation, consider using AWS managed services instead. In either case, doing a lift and shift or re-architecting your data lake, you'll be using Amazon S3 as the back-end storage platform. Since you're already familiar with your deployed solutions, let's take a deeper look at what a data lake can look like using AWS Cloud and AWS Managed Services. As stated earlier, we literally have thousands of customers running their data lake on AWS using managed services. This diagram provides a high-level view of what a data lake on AWS can look like. As expected, Amazon S3 is at the center of it all. It's designed to scale, it's secure and low cost. S3 also provides simple integration. In fact, many of our cloud-native services already supports S3. You can ingest data to S3 using Snowball, Storage Gateway. You can batch upload data to S3 over Direct Connect using numerous tools. You can stream data in with Kinesis or Kafka. You can use Glue to easily catalog your data and run ETL jobs. You can control access and secure S3 buckets using IAM and KMS. You can monitor and log activity with CloudWatch and CloudTrail. You could use a myriad of analytic services from Athena, EMR, QuickSight for data processing and reporting. You could use machine learning services like SageMaker or Rekognition for predictive analytics and image analysis. If you need to add search capabilities, we have Amazon Elasticsearch. If you want to add natural language processing, we have Amazon Comprehend. If you need to integrate a contact center, we have Amazon Connect. You need to identify PII information in your data lake, you could use Macy. The list goes on and on. Whatever you need, we likely have a service for it. If we don't, we likely will be building it soon, as a lot of our services were created as a result of working backwards from the needs of our customers. It's just the way we do things at Amazon. Also, our managed services are designed to be best in class, which means you'll never have to compromise on performance, scale, or cost when using them. For example, Amazon Redshift is 3 times faster and at least 50% less expensive than other cloud data warehouse solutions. Spark on Amazon EMR runs almost twice as fast as Apache Spark 3.0, and you can run petabyte-scale analytics with less cost than traditional Spark clusters. As I mentioned earlier, S3 Intelligent Tiering can save customers up to 70% on storage by automatically decreasing costs based on monthly usage patterns. The key takeaway is that we really make it easy to migrate and modernize your data lake. Yes, you may have to get a little familiar with our cloud services and some of our managed services, but once you do, it really is an easy way to modernize your data lake. So let's look at some real use cases for customers that migrated, and let's see what kind of problems we have solved. Let's start with Gameloft. It's an excellent use case. Gameloft has 275 games with over 80 million active users worldwide. Gameloft actively needs to analyze gaming data to provide various insights to their employees across all their gaming departments. What you see here is Gameloft's previous on-premise data lake and analytics pipeline architecture. They used a combination of custom software and open source technology like Cassandra, Hadoop, Spark, databases, and many other tools. They've deployed this architecture in their own data centers in Canada and China. So let's review the data flow to understand this use case. Every game generates data, and this data is sent to client-facing servers to validate events and push data further down the pipeline. The Cassandra cluster is used as a hot data layer, indexing data by the second. It provides real-time data and retains raw data for 7 days, which is used by other applications and users. Then a series of processes are run to transform and load the data onto their Hadoop cluster. They're basically transforming files into either CSV or Parquet. And this data, in turn, is used by a small team of users at Gameloft. Now, Gameloft moved to AWS for several reasons. Their data pipeline architecture worked fine for 7 years, but then several challenges surfaced. Maintaining their custom client-facing code became more difficult. They also needed a much better way to deliver data to a larger group of users. The performance of the Hadoop cluster began to degrade as more and more data was ingested. Also, upgrading their Hadoop cluster would be expensive due to the 3x replication scheme HDFS requires. Scaling was also a problem with Cassandra and the client-facing servers. Hardware and system monitoring solution needed refreshing as well. There were many employees complaining about wait times for resources as well as poor performance from the Spark cluster, even though the Spark cluster had 1.5 petabytes of RAM and over 500 cores. Developers were also complaining about infrastructure access for testing new application and resources, so productivity did suffer. When migrating to AWS, Gameloft moved their client-facing applications to containers running on the Rancher software stack. They were very familiar with that stack, so they did not opt to use our ECS or EKS. They migrated to Amazon Aurora for the database solution and front-ended everything with our Elastic Load Balancer, which we also call ELB. Let's follow the flow now with AWS in place. So as game data comes into ELB, the data gets processed by client-facing applications, then passed to multiple Kinesis streams. The big difference now is that ELB, Amazon Aurora, and Kinesis are fully managed cloud services. So the administration overhead went way down once they migrated to AWS. Also, Kinesis allowed Gameloft to scale up and down the streams as needed. Since their traffic is not linear, this solution provides better efficiency and more cost savings. For real-time use cases, a microservice is used to filter out additional data, and Kinesis is used again to deliver real-time data to various Gameloft users. A key objective for Gameloft was to create a data lake environment that would allow easier data exploration to more users and accelerate time to value of their data. For the data storage and analytics layer, Gameloft chose Amazon S3, Athena, EMR, and Glue. Their old system had 2 layers of raw data, again, the CSV and Parquet files that were stored on Hadoop. Different systems were used to access those files, and again, only a small team of developers had access to the data. With the move to AWS, Gameloft easily integrated Kinesis Firehose with the Kinesis streams to persist raw data directly to S3. EMR is used to cleanse, segregate, partition, and enrich data. Also, EMR's auto-scaling feature resolved the performance problems they ran into with their old Spark cluster. With data now on S3, Gameloft was able to provide secure data access to a much larger group of data lake users in a short time, and dramatically improved the managed delivery of data to the entire organization. Gameloft also saw a big improvement with using S3 over HDFS. S3 allowed Gameloft to get much more granular in terms of partitioning. With better partitioning came faster data processing. S3 response times were actually 2x faster over the previous Hadoop cluster. Athena provides fast query access to both raw and cleansed data. And basically, as soon as the data land on S3, they were able to use Athena to extrapolate information. AWS Glue was obviously providing the data catalog services. Athena at this point and EMR are now the de facto tools for raw and clean data exploration at Gameloft. Again, combining multiple AWS managed services improved performance, it reduced cost, and enabled better agility and time to value. To achieve zero downtime is not easy. It was done. Basically, Gameloft used their on-prem Nginx load balancer and the mirror module to gradually duplicate traffic to AWS for each one of their games. Let me click here. So basically, through Nginx, each game was, in terms of traffic going to each game was duplicated to Amazon services. This method allowed Gameloft to evaluate and make adjustments to the different AWS components to make sure everything was good. They could validate the data. And then as they switched more games over and duplicated traffic, more and more data started being duplicated between the two data centers. Nginx was then deployed on AWS, and the mirror module was used again to duplicate traffic from AWS back to Gameloft, providing some redundancy in case they needed to revert any of the games that switched over. So once data duplication was working and tested, the primary endpoint was switched from on-prem to AWS, and the new AWS system went live. This slide shows the migration results. We basically migrated 1.2 petabytes of data in support of over 275 games with more than 3 billion events being processed per day. 4 real-time workloads were also migrated, in addition to 10 data tools that they use were migrated. Again, zero downtime. Total migration time was 6 months. The solution is faster, better, and less expensive than the on-prem solution. Gameloft is now actively looking at adding more AWS services for machine learning and data science use cases. So what were the keys to success and the lessons learned here? In this particular use case, data duplication was key. Although this approach does increase initial upfront costs due to over-provisioning, it does enable better testing, data validation, and transition. Also, S3 is a game changer. It increased data usability, data lake performance, interoperability, and time to value. Administration overhead went way down with the new architecture. The ability to revert provides a good safety net. They did have a problem with one game, and they had to temporarily revert to troubleshoot. It was a gaming issue, had nothing to do with AWS, but the fact that they built in that safety net was a very good design, in my opinion, and something I would recommend to other customers as well. So the lessons learned and the tips basically is that AWS really did provide them a lot of numerous services to help get a lot of value out of the data. The S3 storage layer made things very easy for a larger group of people to get access to the data. So I would recommend using as much cloud native services as possible. It will modernize your data lake, and I, from experience working with many customers, simplify a lot of things as well. Let's look at another use case. FINRA's use case is a great example of how to drive petabyte-scale data analysis in the cloud. FINRA is a financial regulatory authority. They oversee nearly all the equity markets today and some of the option markets. They hit a wall with the amount of curated data they needed to serve their users with their on-premise architecture. After copying multiple petabytes of data to Amazon S3 and re-architecting their application using Amazon ECS, EMR, and Redshift, FINRA's storage and application performance problems went away. An overview of the solution is shown here. As users submit their data requests to FINRA's app running on ECS, Hive jobs get launched on EMR to access data in S3. From that point, a subset of the data is used to create a data mart on S3. Once the data mart is constructed, more processing is done on ECS, and a determination on which query engine to use is made, either Presto or Redshift. The simple queries went to Presto on EMR, and the more complex queries were directed to Redshift. In summary, moving to AWS allowed FINRA to easily scale their application using different query engines was something they learned that enabled them to support more use cases and improve delivery results to their users. Let's look at another use case. Alert Logic is a large SaaS-enabled managed detection and response provider with over 4,000 customers operating 24/7. Their data lake solution uses ECS, Kinesis, Lambda, and of course, Amazon S3. Their architecture supported 2 workflows, data ingestion and search. Let's start with the data injection. When data comes in from numerous security appliances they manage, it's fed into Kinesis. Pre-processing is done on ECS. Before landing on S3, their data lake is roughly 25 petabytes in size. With the search workflow, that came from customers, that also went to ECS. This particular workflow used Lambda for processing. In fact, Lambda spins up thousands of Lambda functions to filter, enrich, and extract meaningful security details out of the data and store them in another S3 bucket for searching. Now, what's I like about this use case is Alert Logic ran numerous stress tests against this deployed architecture. They generated 40,000 queries and observed 18 million executions. The Lambda fleet expanded automatically to support 55,000 concurrent functions and then automatically shrunk back to 0. The data lake solution is modern, efficient, cost optimized. Let's look at one more use case. This is with Viber. Viber is a communication platform with billions of users worldwide. They process 10 to 15 billion events per day, with peaks reaching roughly 300,000 events per second. Let's look at their workflow. The Viper backend consisted of thousands of EC2 instances. So just imagine a very large fleet of virtual machines represented by this box in the diagram here. The EC2 instances sent events to Kinesis. And when the streams also were directed from Kinesis to Apache Storm, and Apache Storm was used for their real-time data processing needs. Kinesis also streamed data to Firehose, which in turn sent the raw data to S3. Now, Apache Storm did have some problems. They basically couldn't batch all the events into a single Parquet file without running into some memory issues. So EMR was a good solution to periodically convert these files to Parquet. Another good solution Viber migrated to, they used to use Presto for business intelligence and analysis, but Athena, Amazon Athena, was much faster for a variety of their use cases. So a big lesson here that was learned is transforming the event files to Parquet provided a big boost in performance. So don't underestimate the value of using optimized file formats and columnar, data storage. All right, let's press on. Here's another interesting use case which focuses on high performance computing applications. Some of our customers have HPC data lakes workloads that need access to a high-performance file system that is also POSIX compliant. Note that S3 is not a file system. It's a high-performance, web-based, API-driven object store. We created FSx for Lustre to provide our customers with a fully managed, high-performance file system that can be spun up in minutes using the AWS FSx console. FSx for Lustre can easily link to your data lake on S3. You can transparently run your HPC applications against data sourced by S3, but available in the Lustre file system for HPC processing. When the processing's done, you can output the results back to your S3 on Data Lake. It's a very nice integration between two different storage products. You can get more information on FSx for Lustre at that link I'm providing at the bottom of the slide. All right, let's talk about lake formation. If you need to build a data lake quickly, this is your answer. AWS Lake Formation can do that. You could move, store, catalog, and clean data really fast. You simply point lake formation to your data sources, and lake formation will crawl them and create an S3 data lake for you. It'll transform the data as well. It supports Apache Park and Apache Parquet and Orc. And the best thing I like about lake formation is that it also enforces security policies across multiple services. You can use lake formation to centrally define security, governance, and auditing policies in one place and enforce those policies across multiple services that access your data lake. That's a very difficult thing to do in the real world. Lake formation is also a key component of the lakehouse architecture. We have a Tech Talk recording that covers the lakehouse architecture in more detail, so please take a look at that when you can. All right. I briefly mentioned Storage Lens earlier. It's a fairly new service that offers a lot of value in my opinion. Before S3 Storage Lens, many customers were kind of building their own applications and aggregating data just to report on S3 storage growth, which I thought was tedious. So Amazon S3 Lens provides visibility into the object storage usage with just a few clicks in the console. S3 Storage Lens, it's built natively in S3. You can get a single view of all your S3 usage, activity metrics, trends across your entire organization with drill downs to generate insights at the count, bucket, and prefix level. If you are building a data lake on S3, this is definitely a tool you want to use to get insights at the storage level. S3 Select is another great feature that operates again in that S3 storage level. S3 Select lets customers scan objects in S3 using SQL queries, returning only the data that matches the queries. I've seen many customers use S3 Select to help them with quick schema level validation and file data checks. It's very useful if you're running into query errors because of a bad schema. S3 Select can also help with query engines such as Spark, Hive, and Presto by scanning multiple objects inside S3 without needing to fetch and process all the data. You can use S3 Select with our SDK for Java, our SDK for Python. You can even use the AWS CLI. I definitely recommend your development team look at this. It could speed up data lake applications performance up to 400% in some use cases. Okay, performance tips. Data lake performance is strongly dependent on how you organize data on S3. So even though S3 is extremely scalable and it offers great performance, you do have to be very careful with how you organize the data. When you programmatically upload objects, you need to use prefixes to organize your data, and you need to pick very good prefixes. You don't want to create inadvertently any hotspots. So partitioning and bucketing can be a very powerful tool to increase data lake performance. You want to partition your data across common query filters like date, ID, time, etc. This will reduce the amount of data scanned per query. You could use bucketing techniques on columns with high cardinality and uniform distribution. Store your data in columnar formats like Parquet and Orc. We saw big benefits with the use cases I mentioned earlier. Also, file sizes. You don't want to use too small of file sizes because there's going to be a lot of round-trip traffic. What I've seen work well with customers is 256 megabytes and above. That improves performance and limits round trips. If you're planning a large data migration in one shot, you definitely want to work with our S3 team and pre-partition your prefixes before loading the data. So those are key performance tips I wanted to share with you. I'm going to end on this slide before we get into the Q&A. I basically want to make a clear statement here. AWS can handle any analytics workload. We at any scale and at low cost. I know that's a bold statement, but it's true. We have customers and use cases and the financial data to back that up. I put this slide together to highlight some of the pertinent services I think you should consider for deploying a data lake on AWS. This is by no means a complete list of our services we can offer you, but it's a good breakdown of the core machine learning services, analytic services, and data movement services that we discussed today and the presentation. So thank you so much for your time, your consideration. I hope you did get value out of this. Please post your questions in the chat area or question area, and we'll get to them one by one. Thank you so much.